All right, today I'm going to do multiplying matrices. Multiplying matrices, I'm going to use these matrices for all my multiplications. Multiplying matrices are a little bit different, okay? With adding and subtracting, they had to have the exact same dimensions. With multiplying matrices, they don't. What has to happen is that the columns in the first matrix have to match the rows in the second matrix. So what that means is before I do any multiplication, I want to actually write down the name of the matrix and make sure that the columns in the first matrix match the rows in the second matrix. So what does that mean? If it tells me A times B, I'm going to look at the name of A. A is a matrix that has 2 rows and 1 column. So this is A, 2 by 1. B is a matrix that has 1 row by 2 columns. So it's a 1 by 2. So the columns in my second matrix have to match the rows in my first matrix, which I'm going to put a box around them. They're 1 and 1. They do match. That means that I can multiply these two together. The resulting matrix will be the shape of the rows of the first matrix and the columns of the second matrix. So what that means is essentially these cancel each other out and we're left with a 2 by 2. So we're going to have matrix AB that is a 2 by 2 when we're done. So I'm going to set up a 2 by 2 for when I'm done. 2 rows, 2 columns, okay? And then I'm going to show you guys how to do these. So the first row of A is going to end up in the first row of the resulting matrix. The second row of A is going to end up in the second row of the resulting matrix. The first column of B is going to end up in the first column of the resulting matrix. And the second column of B is going to end up in the second column of the resulting matrix. So I'm using these highlighters to kind of keep all the information where it needs to be. So what happens? I multiply this row by this column. So it's going to be 2 by times 3. I multiply this row times this column. So it's going to be 2 times 4. Notice that the 2 shows up in both of these, and that's what I highlighted here. From this row, I get this row, which is the 2 and the 2. Now I'm going to multiply this row, the second row, by the first column, so 1 times 3. The second row by the second column, 1 times 4. So notice this row showed up in both of these. Also notice this column right here is in both spots of this column. And this column is in both spots of this column. So there's a pattern that we're going to establish here. So matrix AB 2 by 2 is going to be 6, 3, 8, 4. I'm going to keep using these same matrices, okay? So hopefully you have them written down or something. I'm going to do B times A. Now I'm still going to name them to make sure I can do it. B is a 1 by 2 and A is a 2 by 1. These do match and my resulting matrix is going to be a 1 by 1. So multiplication, when you're doing just numbers, it doesn't matter which order you multiply them in. With matrices, it does. So our other matrix, when we did A times B, we got a 2 by 2. But when we do B times A, we get a 1 by 1. So 1 by 1 means I'm just going to have one number, my whole entire matrix. So we're going to follow the same process that I did on the other one. The first row, so B, the first row is 3. And we're going to add the other part of the row, which is 4. So I'm going to do 3 times something plus 4 times something. That's the first row of B. And now we're going to multiply it by the first column of A. So the first column of A is 2 and 1. So I do 3 times 2 is 6, 4 times 1 is 4, 6 plus 4 is 10. So we're multiplying the row of B, which is 3 and 4, times the column of A, which is 2 and 1. And we add those together, okay? Now for the really hard stuff. I'm going to do matrix C times matrix D. Matrix C is a 2 by 2. and matrix D is a 2 by 2. I can multiply them, and it's going to have a resulting matrix that's also a 2 by 2. So the first row of matrix C, try to put this here so you can see it. Nope, just kidding. The first row of matrix C is 2 and 6. So I'm going to do 2 times something plus 6 times something in this first row here. 2 times something plus 6 times something. The second row is 3 and 4. So I'm going to do 3 times something plus 4 times something. Now I'm going to use the column. The column's on D. So D, the column is 1, 0. So it's going to be 1, 0. Notice that these go across, not up and down. That's the most common mistake that I see. And it's going to be right here, 1, 0 as well. Second column is negative 1, 3. Negative 1, 3 is going to go here and here and here as well. Then I'm just going to do the multiplication. 2 plus 0 is 2. Negative 2 plus 18 is 16. 3 plus 0 is 3. Negative 3 plus 12 is 9. So my new matrix is 2, 16, 3, 9. Hopefully that makes sense. I'm going to do one more example, okay? I'm going to do matrix D times E. D is a 2 by 2. E is a 2 by 2. I can multiply them. So DE is going to be a 2 by 2 because of the outside values. So I'm going to put it together. The first row in D is 1 and negative 1. The second row in D is 0 and 3. The first column in E is negative 2 and 6. The second column in E is 3 and 10. I'm going to do that multiplication. Negative 2 minus 6 is negative 8. I'm going to put it up here. 3 minus 10 is negative 7. 0 plus 18 is 18. 0 plus 30 is 30. So that's the final matrix. Hopefully that made sense. If you got questions, let me know.